Hello and welcome to Equations of Lines. This has to do with Chapter 13, so let's jump in. Slope-intercept form. When a linear equation in two variables is written in slope-intercept form, it looks like y equals mx plus b. Let's go through and identify what those letters are. Where y is a y value and a coordinate. Where m is the slope. And where x is an x value, and where b is the y-intercept. The y-intercept, or b, can be written as a coordinate pair. That's the open parentheses, 0, comma, b, close parentheses. Excuse me. Let me get up here to the beginning. So we want to write the equation of the line with the slope and y-intercept. So remember we have y equals mx plus b, where we have m as the slope and b as the y-intercept. So for this, we have y equals mx plus b. So we're going to replace m and b with the given information. Y equals m is 3, x plus b, which in this case is negative 2. So we have y equals 3x minus 2. Okay with here, y equals mx plus b. We have y equals 0 in for m times x plus a negative 8. We simplify, we have y equals 0 times x is 0, and then we're left with just y is negative 8. With the third example, y equals mx plus b, we have y, we're going to replace m with 1/2, x plus 0 in for b, and that just simplifies to y equals 1/2 x. Okay, and finally we have example 4, y equals mx plus b. We're going to replace m with 0. We're going to replace b with 0. So when it comes down to it, y just equals 0. Okay, and we're going to talk about using slope-intercept form to graph an equation. So we plot the y-intercept first. Remember that was the b of the y equals mx plus b form. From the y-intercept, find another point in the line using the rise over run. That's going to be where the m is some number, and it can either be a fraction like this, it can be a negative, it can be 0, it can be a positive number, and for numbers like this, remember numbers can be written as over 1. And this is going to be rise, so you go up or down according to sign, and then you move left or right according to sign. You move up for positive, didn't spell that correctly, and you move down for negative. You move left for negative, and you move right for positive. Okay, so say you were given y equals mx plus b, where m was 4x plus 2. What you want to say in this case is that you want to plot the y-intercept, in this case it's 0, 2. You plot that. Then you use the slope, which is 4. Remember, it can be written as 1 over 4, so since both these are positive, you're going to go up 4, and then you're going to go to the right 1 and find your next point. So let's get our hands dirty with some examples, graphing these kind of things. So we have y equals 3x plus 4, identifying that the slope is 3, and we say that's over 1, and b is 4. You can write that as 0, 4. So let's graph this 0, 4 first, which is plotted right here. Now using our slope, we're going to go up 3 and then to the right 1 to find our next point. So we go from our point that we're starting, the y-intercept, we go 1, 2, 3 up, and then 1 to the right. And then you can also reverse it if you want to find another point and use the opposite of each. You can say go down 3 and then go to the left 1. So from our starting point, you go down 3, so 1, 2, 3, and then to the left 1. So there's our next point. And then to graph this, you want a solid line, and that's awfully bold, but that's how it looks. And I like to put little arrow marks to show that the line continues forever. Looking at example 2, we have a slope of 3 over 4, or 3/4. B looks like it is 5, so it can be written as 0, 5. Start off by plotting 0, 5, which is right here, and then use your slope of rise, so go up and then run to the right. So go up 3, 1, 2, 3, and then go to the right 4 places, so 1, 2, 3, 4. You can also do the opposite for another set of points. So the opposite of 3 is -3, and the opposite of 4 is -4. So go down 4 and then go to the left 3, or go down 3 and go to the left 4. So 1, 2, 3, 1, 2, 3, 4. There's our next point. So now we can connect these and make a line, connecting the dots as best that we can. And there is our line. And remember to draw those arrows on the end of them to show that the line goes on forever. Okay, with example 3, it is not in the y equals mx plus b form, so that's what we're going to have to do. So with this, we have 6x plus 3y equals 9. I want to work with getting this x away, so let's subtract 6x on both sides. We're left with 3y equals -6x plus 9. Now finally, to get the 3 away from the y, divide both sides by 3. We have y equals a -6 over 3, or a -2x. And finally, we have 9 divided by 3, or just 3. So our slope is -2. You can say it's over 1. And our b is 0, 3. So let's graph 0, 3. It's right there. Now use our slope of -2, so go down -2 and then go to the right 1 to find our next point. So there's down 2 and to the right 1. And you can also do the opposite of that and have a +2 over a -1. So you're going to go up 2 and then to the left 1. And if we were to plot that, go up 2 and to the right 1, to the left 1, excuse me. And there's the other point. So now what we can do is use our graphing tool here and graph these points, connecting them best that we can. And then adding arrows to the end to show that the line goes on forever. And now I believe for our last example, in this case, because I think we're doing okay with time, we want to get y by itself by first subtracting 2x on both sides of the equation. So we're left with 5y equals negative 2x plus 10. To get y by itself, divide both sides by 5. This is going to leave you with y equals a negative 2 over 5x plus 10 divided by 5 or just 2. So that means your slope is m equals negative 2 over 5 and then b equals 2. Or that just becomes the point 0, 2. So what you want to start off by doing is graphing 0, 2, which is right there. Then using our slope of going down 2 to the right 5, go down 2, then go to the right 5. And there's your point. Okay, that did not turn out so well, so let me try that again. Okay, that's better. And then add your end marks to show the line goes on forever.